Okay, so for something like 3.3, right? What does it say here? It says we need to get an angle somewhere. But then the angle we're trying to get is not at the x-axis. Oh, okay, it's an angle here. Okay. So I mean, like, depending, as mentioned already, right? Like the way our sketch looks should always help us. And the other thing with analytical geometry is the previous questions that should have been asked. I mean, like 99.99% of the time. Okay, let's just maybe say 95% of the time, you're going to need to use them. So if we need alpha, right? They asked for the gradient. Initially they asked for the gradient of AC. So one way or the other, that can help us get this angle.
Yes, it does.
Yeah.
It's 12.
If we ever, nice. And then it says determine the equation of ED or DE. So the equation of DE is not so bad because as long as you have the gradient of AC, it will be easier, right? To like get ED. Okay. And then next, they then ask for alpha. And then what's the marker location for the angle alpha?
The angle alpha, the marker location is 3.
3. Okay, so that's already something that should put our mind at ease, because I mean, like 3 marks is really not a lot, you see. Now, depending on the angle that they're asking for, we don't want to limit ourselves to just thinking around where this angle is. We want to be creative, you know, as creative as we can be. Like we can do whatever we want to do actually, as long as it's going to help us work out alpha. So one of the things that is productive is looking at where alpha is. What you can do for yourself is to try and write alpha somewhere else in the sketch. Like for example, this is alpha, right? Do you see that this angle here is 180 minus alpha? This
Which
one.
angle?
That one.
Oh, yes.
Yeah, so you might as well even write it out, because the reason for thinking this way is because, I mean, remember we said we can get this angle. So if you're looking at this right angled triangle here, this is more useful to us because there's a 90-degree angle here. And then as we said already, this angle, we can write it as 180 minus alpha. And then in this triangle, we have something that has alpha in it, meaning it can also help us to work out the question.
Oh,
yeah. So you said, what is the gradient of AC?
2/3.
2/3. So we can use the tan formula to help us get the gradient. But before we even do that, you see, it goes back to the name of the topic, analytical geometry. We just have to analyze the sketch, you see. So here we can have the tan reference angles. Let's just name it theta is equal to what? You say 2/3?
Yes.
2/3. So here, okay, we're talking about angle FGO, right? But anyways, let's see reference angle here. Let me just replace this with FGO, just so that we are all on the same page. FGO. So the reference angle here is going to be shift tan 2/3. What does this give us?
That gives us 33.69.
Okay, so 33.69. This looks accurate enough to be it's an acute angle, so we can just take that as our value for FGO. Do you see?
Yes.
Yeah. So we have this angle, we have 90, and we have this thing here. We know that everything adds up to 180. You see, so we might as well use that to our advantage. So let me remove this. Remove this crop. So now I have space here. So here we can say 33. Yeah, now 33.69 plus this angle up there, plus the 90-degree angle there, this O should equal to 180. The reason is just interior angles of a triangle. We said for analytical geometry, you don't have to write the reasons, but it's a good habit to form. So here, we're gonna have 33.69 plus the 180 minus alpha. And then here, if you take alpha to the right, alpha is gonna be a positive number now. And then if you take the 180 to the left, I mean, like those will cancel out. So it's like this plus the 90. I think this is where the whole plus 90 issue comes in. And then alpha is 100 and but do you see this is more like a long dry, because it looks like the easiest way to have actually just done it is to see that this is an exterior angle of a triangle, because you see this is a straight line. So you have an exterior angle here. It's equal to the sum of the opposite ones, meaning it's equal to this angle plus the 90. But whichever way, everything always works out.
Okay.
You see it, right?
Yes, I
Nice.
see.
Oh, nice, nice. So let me bring back that picture of ours. Nope, that's not it. Yo. Oh yeah, so was there something else on this specific sketch?
Something else I didn't understand.
On this sketch?
No.
Okay,
Everything
okay.
else was right. It's just the angle.